Hello everyone, welcome to the class and let me just check if I'm online. Right, okay. So today also we're going to see all about congruent forces. So let's start today's class, and my name is Mohana. I'm a physics educator here at Unacademy. So I'll be taking your class 11 and 12 physics, and this is my Telegram channel link. Any updates are there, it will be shared over here. Sometimes I share some pool type questions, so you can follow me on my Telegram channel. And this is the common ICSE and ISE both Telegram channel. You can follow this channel as well. Now, just like how we have the YouTube sessions on YouTube platform, we also have session on the Unacademy platform. Okay, so those sessions are absolutely free, and particularly those sessions on the Unacademy platform which are free, we call them as special classes. You can engage with these educators via pool feature during special classes, and also those classes are also live classes. So any doubts you have, you can get them cleared then and there. Now, in case you wanted to join my upcoming special classes, go to the description box. There will be a link to the upcoming special class. It will be written as class 11, right? So click on class 11 special classes. It will take you to this month's upcoming special classes. Okay. Now you can just click on the notify button. So upcoming before the class goes live, you will be notified. Now we have another class tomorrow. So in this class, remember we are doing dynamics unit, but we have started from part of this unit where it's from equilibrium, right? So the first part of your dynamic unit, where we talk about the first three laws of motion, right? Newton's laws of motion. It is actually done on the Unacademy platform. Okay, so we will have one more class tomorrow at around 7:45 on the Unacademy platform. We will have this tips. Okay, likewise, next on 27th July on 7:45. We have done till now about for motion in a plane so many classes, right? We have covered motion in a straight line as well. But on 27th July on 7:45 p.m. based on your syllabus, right? Motion in a plane, there will be a quiz on motion in a plane. So if you still have any doubts on vectors, join the class. Okay, you can actually get your doubts cleared as well. Now, if in case you're interested in the on the subscription plan, on the plus subscription, these are the advantages you'll be getting. One is you can learn from the comfort of your home. Next is you'll get unlimited access to all courses. So whenever you're taking a plus subscription with Unacademy, you are actually taking 4 subjects. That is, you'll get physics, chemistry, math, as well as biology. Okay, so the payment you're doing is for 4 courses subjects. All right, and you'll be learning from the top educators, and every 4th session, right? Let's say a plus course starts this day, every 4th session of a plus course is a doubt clearing session. Okay, so first 3 days, all classes are live. You can ask whatever doubts you have, you can ask. But at the same time, every 3 classes, after every 3 classes, there will be the 4th session as a doubt clearing class. Again, we can revise the concept, we can learn something new over there, or if you have any doubts in the previous classes, you can ask about the same as well. Okay, now in the plus classes, we'll cover your entire subject, and as well as you will get lots of practice tests, and every other weekend there will be a live test series. So in the live test series, right after that, you will have an analysis session. Okay, so during the analysis session, whatever tests that you've taken, right, for all the questions there, if you still have any right, if you had made any mistakes, you can actually learn the if in case you made any mistake in the test series, then you can actually learn the right solution. If not, if you want to know what is the shortcut, you can learn about that as well. Okay, for the upcoming batches, I would shortly give you those details. Before that, the pricing with Unacademy, if you see, the longer duration you take a course, the price per batch per month goes down. Okay, let's say you're taking a course for 1 year, then the price per month goes down up to 1,653 rupees. Okay, same time, if you're taking for 2 years, it will be 1,378 rupees per month. If you're in class 10 and if you want to take for 3-year subscription, then again you can take 1,176 rupees you can per month. Okay, now in this case, whenever you're taking a plus subscription, you can use my educator code to avail a discount. Okay, right now what we have on the platform is, before July 22nd, any plan that you're taking, right, in case if you're taking a plus class, plus subscription for class 11 or 12, let's say the duration you're taking is for minimum 9 months to 1 year. Okay, and you can actually take for 2 years as well, right? So if you're taking that, then these are the then you are getting a 20% off. That is, for 9 months course, the price range is that 14,615 rupees. So you're saving 2,578 rupees. For 1 year course, you're only paying 60,863 rupees and you're saving 2,975 rupees in total. Okay, so this amount that you're paying is for 4 subjects: physics, chemistry, math, and biology. Okay, and also if you're taking for 2 years, it's 28,104 rupees and you're saving 4,959 rupees. Okay, to avail this discount, okay, to avail your courses for this discounted price, right, you can use my code MTIS10 and you'll get an instant 20% discount. This is available only between 17th to 22nd, especially only when you're taking a 9 months course and above. Okay, now the ongoing class we have for class 11 is actually the Brahmastra Plus course. So this course actually started on July 6th. In case if you missed any classes, don't worry, class recordings will be given. Every 4th class, as I told you, is a doubt clearing session. During the doubt clearing session, you can get your doubts cleared, right? Now, this course is actually will be taught in English, and for physics, we meet every 5:15 to 6:15, Tuesday, Thursday, and Saturday. Okay. Again, math, Rahul sir will take, Manisha ma'am chemistry, she will take chemistry, and Lakshay sir will take biology. Now, whenever you have in any one day, if you see, you will have 2 classes. That is, you will have physics and chemistry on one day and math and biology classes on one day. So, in a month, if you take, you will have a minimum number of classes if you're taking, right? In a month, you will have at least, this is the minimum number of classes you're getting for each of the subject, okay? Overall, if you say in a month, you will get minimum, at least you're getting 40 classes per month. Okay, which means other than this, there will be lots of test series are available, and also you can actually go for the analysis session, and all other classes are there, but at least 10 classes are there. Okay, each class being at least 10 classes per subject is there. Okay, 10 in this case, per class duration is about 1 hour. Okay, now you have an advantage that if you're taking a class 11 subscription, your class 12 subscription is absolutely free. Okay, once again, to avail this offer, and also a 20% discount right now, you can use, I mean, the 20% discount is only still 22nd. Okay, do you do that, you can use my code MTIS10. Similar to class 11, class 12 also we have a plus batch. Again, the batch is taught in English, and the course started on July 6th. And for physics, we meet between 5:15 to 6:15 every Monday, Wednesday, and Friday. Now, the focus of both Achievers and Brahmastra batch is your midterm syllabus coverage. After covering your term 1 syllabus, we'll move on to term 2 syllabus. Okay. Now, on that note, let's start today's class. Now, yesterday we learned that what is a congruent force, right? Very simple concept. A congruent force is nothing but if there are forces, if there are multiple forces acting on the same point on a body, then we call it as congruent forces, right? Next is equilibrium of congruent forces is very simple. Okay, if you have large number of forces acting at the same point, for example, let's say there is a weight, okay, and all of these weight, let's say you're applying a force in this point over here. Okay, so at this particular point over here, there is a force acting in this direction, right? There is a tension force acting downwards, right? And let's say because you're applying a force, this thread gets extended, right? So there is another force acting in this direction. There are multiple forces acting on the same points, right? Now, another example you can take is, let's say like you are actually taking let's say you're taking a cart and you're pulling this cart over here, okay, applying a force. Now, frictional force will act in the opposite direction, right? Now, there are multiple forces acting on the same point, right? Now, if all of these forces are balanced such that, right, force F1, F2, how much ever forces are acting on the object doesn't matter, okay? If all of them are balanced, then the object will be at rest, or if it is in motion, it will continue to go in motion. Why? All of these forces are equal to 0. Okay, so in such a congruent force, we say in such case the congruent forces that is acting on a point, if they are all balanced, if the net unbalanced forces is coming up to 0, then we say that particular system is in equilibrium. Okay, the condition for the equilibrium of is that if number of forces acting at the same point is that vector sum, okay, of individual forces is equal to 0. Okay, now we saw this in the last class, so let's just do one example and move ahead to the next concept. Okay. Now, let's say you have a pendulum. Okay, let's say there is a train, and inside the train to the roof we have attached a pendulum. Okay, now the train starts moving, right? As the train starts moving on its horizontal track, right? The train starts moving. What will happen? Now, this is at rest. The train was also at rest initially, right? As this train start moving means acceleration is given to the train, right? So force is applied on the train, so that will start moving, right? But this pendulum is actually at rest, right? So according to inertia of motion, what will happen? At inertia of rest, what will happen? This pendulum will start swaying, right? So this pendulum will start swaying, it will start moving. Okay, now as this moves, it makes an angle, okay, and this angle theta it makes, according to this question, it is given as 10 degrees. Okay, so it's making an angle theta with the vertices, right? That's at 10 degrees. Now we have to find what is the acceleration of the train from this. We are going to take g to be 10 meters per second square, right? How do we find the acceleration from here? It's very simple. Okay, first we will see what is the tension, right? Here, as this bob over here moves this side, see, this bob is attached to the string over here, right? So there will be a tension force acting upward in this direction. Okay, since this bob is attached over here, right, it has a mass and it will also act downwards because of acceleration due to gravity. So the weight of this particular bob will act downwards, the tension force will act upwards, right? Now, if you see this tension force, if you take into account, this can be resolved into two vectors, right? One is along its, we can say along its horizontal. Another vector you can resolve will be along its vertical. Okay, so if you're resolving this into two vectors, okay, now if you see this angle is theta, means this angle will also be theta. Okay, now if this is theta over here means, okay, how do we find this angle over here? How do we find this base over here, right? If you want to find this particular direction, what is the force acting on the, what is the component on this side? This angle is theta, right? How do we find the component acting on this side? So this will be opposite to the angle, right? This side will be, we can take this angle to be sine theta, right? If you take this angle to be sine theta is basically the opposite or the perpendicular by base, right? Perpendicular we don't know, we want to find, right? So that is that x by the base is over here is t, right? So from here, what is this perpendicular force that we are seeing? That is t sine theta, right? So this value that we are seeing over here is this particular tension force component over here is going to be t sine theta. Okay, now what about this case, right? So from this angle, if you want this side, okay, we know that vectors are also, we can move the vectors, right? Because vectors, you can do commutative as well as they are associative, right? They obey the commutative and associative laws. So what we can do is we can move this vector to this side. Okay, so what we are going to do, we are going to do the same. We have a tension force T acting on this side. We have this side, right? This vector we have on this side, we are going to move it over here. Okay, and we know this side is actually T sine theta. This angle is theta. This vector we just moved it to this side. Okay, now what you want is, you want to find this side, what will be the value. Okay, for that let's take this x, right? So this will be cos theta. Cos theta is its adjacent or is the base side over here. That is actually x by perpendicular. Perpendicular is again this tension force T, right? From here x you will get it as T cos theta, right? So this angle over here, this tension force over here that you're seeing, this vector over here is T cos theta. Alright, so we have resolved all the components. Now from here, how can we find acceleration, right? Now this angle, if you see, the angle component, if you see everywhere, this angle is around 10 degrees. So we can write the same. The angle is around 10 degrees, right? Okay, now, so if you see over here, okay, if you resolve the horizontal components, right? horizontal components over here is equal to, what are the two horizontal components here? We have this t cos 10 degrees. This is opposite to this vector will be equivalent to this vector over here, right? So the horizontal component will be equal. Okay, so this side it will be t cos 10 degrees is equal to, maybe I should draw this vector big, right? This will be, this is the weight acting on the object, right? W, weight. Weight is mass into acceleration. Mass into acceleration due to gravity, G, right? Okay, now this is one force. Now let's say the other component. The other component that we are seeing over here is actually nothing but your vertical components, right? This becomes your vertical. Now let's resolve your vertical components. Okay, this is horizontal component, vertical components we have taken into account. What about horizontal component? On one end, we know we have t sine 10 degrees, right? Now, this is the direction in which the train is moving, right? This is the direction in which the train is moving. So, as the train is moving, it has a mass and it has an acceleration, right? So, the force is in this direction, right? The force applied for the train to move is in this direction. So, here what we can say, this t sine 10 degrees will be equal to mass into acceleration due to gravity, because that's the direction in which the train is moving, right? This vector is pointing toward the direction in which the train is also moving, right? The train has a mass and also has an acceleration. So there was a force applied for it to move, right? So this particular vector will be equivalent to this. Now from here you want to find G. Okay. So if you want to find G, one thing you can do is you can divide these two values, right? So you can say take t sine 10 degrees by t cos 10 degrees, which is equal to mass by acceleration, it's mass into acceleration due to gravity, right? So here what you will get, sine, t and t gets cancelled, sine by cos is actually tan 10 degrees, which is equal to mass gets cancelled, acceleration into gravity, right? So here, from here, if you take, your acceleration is nothing but g into tan, acceleration due to gravity into tan 10 degrees, right? Acceleration due to gravity from the question is given as 10. Now what is tan 10 degrees? Okay, so if you take tan 10, let me quickly get the value. Okay, tan 10 degrees is somewhere around 0.18. Okay, that's the value. All right, so okay, so from here if you see what is acceleration due to gravity, 10 into 0.18 is 1.8, right? So the acceleration in this case, the acceleration of the train is going to be around 1.8 meters per second inverse second square, right? So in this case, the acceleration, the train's acceleration is going to be 1.8 meter per second square. Okay, right. So we have done this. If you have any doubts, please ask me in the chat box. And right, so this was one example connecting to your congruent forces, right? Now let's see what will be the motion, okay, of connected bodies. That is, for example, let's say there are two weights that is hanging over this pulley over here, right? Let's say the mass of this particular object, let's take it as, let's take this has a mass m, and let's say this has a mass m over here. And this particular, the mass, the capital M, the mass over here is greater than this mass over here, right? So what will happen? So in this case, the heavier mass will start to move downwards, right? If you attach two strings and attach two masses over here around a pulley, now the one with the heavier mass will start going down and the one with the lighter mass will start going up, correct? So that's how they're going to move. So both of these is going to have an acceleration, but here this one's acceleration is going to be downwards. This mass's acceleration is going to be downwards because it's going to come, because this one is heavier. Let's say this is 10 kgs and this is 1 kg. So 10 kg mass will start moving down, right? So it's going to move. As it moves, it's going to cover some distance with time. So that is actually nothing but velocity. Velocity by time, change in velocity with time gives you acceleration. So this is going to accelerate downwards, wherein this mass is going to accelerate up. right? So this is going to move up, so we can say this is going to accelerate upwards. Okay, now as this rotates, right, as this rotates, we can say that this is the direction in which it's rotating. Now as this rotates, there's going to be a tension which is developed on the rope, right? So there's going to be a tension force acting upwards over here, right? Let's take that as T, and there's going to be a tension force acting upwards over here also. Let's take that as T, and here this weight of this object is going to be mass into the acceleration due to gravity, and here the weight of the object is going to be this capital M into acceleration due to gravity. Okay, and this weight component over here is completely going to balance your tension force on the string, right? Okay, now according to Newton's according to Newton's second law of motion, right, we know that force is equal to mass into acceleration, right? But here if you see, in this case if you see, according to Newton's second law, the resultant force, okay, if you're talking about the resultant downward force on this mass M, right, this particular force, this weight force is going to be this particular force is going to balance, right, this mass into this acceleration. This force is balanced by two forces, right? One is the force over here, right? This force acting over here, there are two forces acting. See, from Newton's law of gravity, second law, we know force is equal to mass into acceleration, right? So on this object, the force acting is nothing but there is one force which is actually acting downwards. This is mass into in the direction, right? It is moving in this direction downwards. This is your weight, right? Weight of the object. So this is acting in mass into acceleration due to gravity, that is downwards, and there is a tension force acting upwards, but it is in the opposite direction, right? This will be minus T. Okay, now we know force is equal to mass into acceleration, right? So if you substitute for that, we know the force over here, mass into acceleration, right? This force over here is balanced by two things. One is the weight acting downwards, and the tension force, this mass, how much tension it exerts on this rope over here, right? So those are the two forces that is acting in this in this case. Okay, now the resultant, this is the resultant downward force. This will be the resultant downward force for this object M. Okay, so we can say this is resultant, and this force resultant downward force. Okay, on mass M, okay, is given by this, right? Now it's the same. What is the total or the resultant upward force? Because this mass is moving upwards, right? The resultant upward force on mass M over here, right? Here this mass is moving upward. This resultant force will be equal to, that resultant force F is equal to, right, this force that is acting downwards, the weight of the object, that is mass into acceleration due to gravity, right? This is acting downwards, but if you see over here, we are talking about the resultant force which is actually upward, because this particular force applied, this is actually moving upward. It's the resultant force, right, on this object over here, it is making this block move upwards, right? So the upward force what we see over here is tension. So this tension force is in the direction of the resultant force over here, right? So this tension force, right, minus what is the weight of the object. Now weight of the object is acting in the direction downwards to the see, the final force is acting upwards, means the resultant, in this case the weight is acting downwards, right? So we have to say these two forces, right? If this is my total force F, right, T is acting in this direction, and if you see weight is acting in the opposite direction. This weight is nothing but mass into acceleration due to gravity. So because it's acting in the opposite direction, we write minus M into G. Okay, so this is the second force over here. Now if you add these two equations, what will happen? If you are adding these two equations, so again over here, instead of force, from Newton's second law, we know force is nothing but mass into acceleration. We'll substitute that mass into acceleration. Okay, and in this case also, this is capital M. Okay, So if you add these two equations that we have over here, okay, we will actually get, okay, we will add these two equations. So we have m into a plus m into a, right, which is equal to mg minus t, right, plus, right, we are adding these two as well, right, t minus mg, right. So let's actually do this value over here. We can take m plus m, right, and we are removing a commonly, acceleration due to gravity commonly outside. From here I am removing acceleration due to gravity commonly outside. Then on the other side we have mass into gravity, right, this one minus the tension force plus the tension force minus mass into gravity, right. This is what we have on the other side. So tension forces over here gets cancelled, and if you take acceleration due to gravity commonly outside, you will have capital M plus small m over here. Okay, so from here if you see, this is m plus m into a, right. From here if you see a, this is nothing but m, right. If you want a, it will be m plus m, right. In this case this will be m minus. This value is minus, and if you take this to the so in this case you will actually have, you can keep this term here, bring this term to the other side, that is m plus m, right, into g. Okay, so from here if you take whatever the value of acceleration is, right, that value of acceleration will be this particular value times the acceleration due to gravity. Okay, so here if you see, we are subtracting on the numerator, we are subtracting two quantities. Okay, so if you're subtracting two quantities and then you're dividing it by the addition of these two quantities, this number, this quantity over here becomes smaller. Okay, if this quantities become smaller, this value times g when you do, right, whatever this value is, this value times g when you do, that will be your acceleration due to gravity. Okay, for example, let's say this mass m is around 2 kgs and this mass m is around 1 kg. Okay, so if you see over here, if you take a value, it will be 2 minus 1 by 1 plus 2, right. Let's take acceleration due to gravity as 10, for example, 10 meters per second square. Okay, so that the calculation becomes easy, just for that reason. Okay, so here what do we have? 1 by 3 into 10, right. 1 by 3 into 10 is what? This is nothing but 10 by 3, right. If you take 10 by 3, the value is around 3.33, somewhere around here you will get the acceleration due to gravity as. Okay, here we have mass, again we have mass gets cancelled, the unit will be acceleration due to gravity is 3, right, for example in this case when we took. Okay, but if you see the acceleration due to gravity, this g value we assumed it to be 10 meters per second square, right. At any case that you're seeing over here, since the above quantity over here we are subtracting them, and down here we are adding them, right, we are subtracting the mass and dividing by the summation of the masses, what will happen? This acceleration due to gravity, this a value will always be less than g. Okay, now from here, okay, that is the acceleration a of these two objects that were there, right, two blocks, is always less than the acceleration due to gravity. That is how much these two are moving, right, this mass moving downwards, this mass moving upwards, the acceleration they have, right, that is always less than acceleration due to gravity. Okay, so because of that, let's divide these two equations, right, equation 1 and equation 2, let's divide these two equations. Okay, so if we are dividing these two equations, then you have mass into acceleration, right. One equation is actually mass into acceleration is equal to, this is for the downward resultant force, right, and the upwards resultant force, if you see, this is actually equal to upward resultant force is mass into acceleration will be equal to right, tension force minus m into mass into gravity, right. Now if you are dividing these two equations over here, then in this case you will actually get, right, all right, so here you can actually write this will be nothing but m by m, right? Then you can actually cross multiply. If you're dividing this, acceleration terms gets cancelled. Let's cross multiply. This will be m into t minus m into g, which is equal to m into mg minus t. All right, now let's actually, right, let us actually bring in these terms, like terms, to the same side. Okay, let's take the terms which has t to the same time. Okay, so here if we are doing that, we get m t minus, let's take this term which has the tension terms to the same side. So this side, when it becomes, it will be m into t, right? Because this is minus mt, to the other side when it becomes plus m into t, this will be equal to mg. When this goes to the other side, this will again become a positive value, right? It will become plus mmg. Okay, now so here you can actually take this m plus m is equal to t. From here we know this is 2 mm, right, into g. So this tension force that you want to calculate, this value will be 2 into the product of the two masses by the sum of the two masses into acceleration due to gravity. Okay, this will basically give you what is this tension force. Now when you have two objects which are connected by a string, and if you want to measure its tension force, right, then this is the formula you will be having. So you have to multiply 2 times the mass of the object, right, divided by the add the two masses, right, the whole value into acceleration due to gravity. So this is the equation you will be using. Now whenever you're solving any problems in mechanics, we are going to make use of free body diagrams. Okay, a free body diagram is very easy, right? It just says, it's just, let's say in this case there is a number of forces that are acting on this object over here, right? Now all of these, it becomes very easy for us to consider how many forces are in total acting on this entire system if we are looking at individual objects that are involved and what are the forces that is acting on them. Okay, so whenever you're talking about a free body diagram, right, it just tells you, right, it just tells you it's just a diagram, okay, for each object or each body, okay, of the system showing all the forces exerted, okay, all the forces exerted on the body by the remaining, okay, by the remaining parts of the system. It's called as a free body diagram. Okay, so just tells you, let's say we have a cart and let's say you are actually pulling the cart. Okay, so as this cart moves, this is the force applied. There will be friction forces that is acting on the opposite side. So a diagram for each body, right? For example, now let's say there are actually two books that are kept one on top of another. Okay, now because it's kept one on top of another, let's say this table over here is not very strong and it breaks and both of this falls down. Okay, so instead of, when you're doing this particular problem, it becomes very easy if we consider each of these masses separately and if you consider what are the forces acting on each of this body. Okay, so a diagram for each body of the system showing all the forces exerted on the body by the remaining parts of the system, is called as a free body diagram. Okay, now that we know what a free body diagram is, it really makes adding vectors much more easier, and actually let's see how to solve a problem using the free body diagram. Okay, now just give me 1 second, guys. All right. Okay. All right. So let's say we have a let's say we have a table over here. On this table, we have actually kept a block, a wooden block. Okay, and let's say the weight of this wooden block, so the mass of the wooden block is around 2 kgs. So a 2 kg wooden block is kept on a table, right? Now this horizontal table, or whatever you're seeing, let's say it's a glass table and it's made of a very light glass, and it cannot stay there. Like, any more further weight you add, it will break. Okay, so you can take it as a very smooth or a very soft horizontal surface. Okay, now right, so let's say now the free body diagram for this particular mass will be very simple, right? So you have a mass here. What are the forces acting on this mass? If you draw that becomes your free body diagram. Okay, now let's take the acceleration due to gravity for this particular program to be 10 meters per second square. Okay, now whenever any object that is placed over here, there will be a weight acting downwards, right? There is one force that is always acting downwards, that is your weight, right? Weight is given by mass into acceleration due to gravity. So what is the weight? What is this force weight that is acting over here? This force weight will be 2 kg mass into 10 meter per second, right? So weight is 20 Newton. So there's 20 Newton of force that is acting downwards. Now, this particular force is kept in contact with the floor, right? Whenever there is a contact force, right, there will be a resultant force that is acting upwards. So whatever the weight, whatever the weight this particular block applies on the table again will apply the same weight on this particular block. So that is your reactant force over here. Okay, this reaction force, if this is W, this is the weight acting downwards, whatever weight is acting on the table, because they are in contact force, the table will also oppose the block over here, wooden block over here with an equal force, okay, but in the opposite direction. So that's your resultant force. So contact forces, there will always be a normal reaction force, okay. This reaction force will be opposite to this weight over here, okay, and it will have the same magnitude, okay. Because this is from Newton's third law of motion, whatever is the action on of the block is, the same force will be exerted by this table on this block. That is your reaction force. This is equal to the same value as your weight. Okay, so that is one. This is one point over here. Okay. Next, what we are going to do is we are going to keep, right. We know that this surface is very can easily break, right? And let's say on the mass on this, we have kept a mass on this, right? This is a wooden block we have kept, which is up to 2 kgs. Now, what we are going to do on top of it, let's say we kept a cylindrical or something that is made of a metal, okay? And let's say this mass that we have kept is around 25 kgs. So obviously what will happen? This table over here will break, right? This table over here will actually break, right? And this object in this case will actually start. Oh, I'm really sorry, guys. Okay, I'm really sorry about that. Just a second. Right, let me quickly get that. right? So the table starts to break, and as this breaks over here, this mass starts accelerating downwards, right? So this one falls first, this mass M, which is actually 2 kgs, this falls first. On top of it, we have kept a cylindrical block, right? This cylindrical block falls next, right? This is around 25 kg, right? This is the mass of this system. Okay, now both of this starts falling down, and when it's falling down, let's say the acceleration with which it's falling is 0.1 meters per second square, right? It's just falling down. When it's falling down, this is the acceleration the system has. So now if you see what is the free body diagram over here, we have a mass, right, which is M1. We saw that this is 2 kgs, and we have a cylindrical metal weight which is kept on top of that. This is mass M2. Now, because of both these forces together, there will be a weight that is acting downwards, right? The weight of this particular object will be given by, right, the weight that is acting downwards, right? In this case, if you see, if you want to calculate, the weight is actually acting downwards, right? This is the force of gravity on the earth, right? This particular weight will be weight of the block plus that particular system. Now, here, what we will do, in this case, the weight will be because of M1 and M2, right? And both are having an acceleration. So, we said G, we will take it as 10 meters per second square, right? In this case, weight will be because of M1, because of M2, what is the weight? Both these weight, and acceleration due to gravity, that is weight. In this case, acceleration G is acting downwards, right? So this will be M1 is nothing but 2 plus M2 is actually 25, right? Into acceleration due to gravity is 10. So this is around 27 into 10. So the weight force over here is actually 270 Newton. Alright. Now, if you are actually applying the reaction force, right, of the floor, if you see, right, this is this particular table, if you see the reaction force, see, this is the weight that was acted on the table, right? So the table will also have a reaction force over here, right? That particular reaction force, if you see, right, this reaction force, if you see, now applying the laws of the system, if we see that will be this weight force, that is 270 Newton minus the reaction force over here, will be equal to the total force acting on the system, right? The force is given by, the total force on this particular system is this weight that is acting downwards minus the reaction force that is acting up. Okay, why we are taking minus over here? Very simple. In this case, this table over here shatters, and the entire object actually starts, the entire block, wooden block and the cylindrical block starts to fall downwards. As it falls downwards, it has an acceleration of 0.1 meter per second square, right? So it is actually traveling, the whole system is actually traveling downwards. So this particular weight force is in the downward direction, that is 270 Newton, minus this particular force, if you see, this force is in the opposite direction. So we take minus R dash. So the total force that is acting on this particular system is the weight minus the reaction force that is acting upwards. Now, how do we give the force over here? Force we know is given as mass times the acceleration. Acceleration is given in the question itself for us. So this 270 minus, we don't know what the reaction force is, but this will be equal to, mass is nothing but, in this case, mass of the system is 25, that is for the wooden block, cylindrical, the metal block over here, plus 2 kgs for the wooden block over here, into acceleration due to gravity is given in the question itself as 0.1. Okay, so this is actually 27 into 0.1, this is around 27, right? 2.7. Alright, now this will be 270 minus R dash, right? Now, what will be the reaction force from here? The reaction force, if you take, that will be 270, right? I am just taking this side and the R this side, minus 2.7. So that is nothing but, this is actually in this case, right. So in this case, if you see, if you actually subtract it, this you will get around 267.3 Newton. Okay. Now this particular, so by the Newton's third law, we can say that this reaction force over here is around 267.3 Newton, right? So if you see this force is 267.3 Newton, means now this particular force is actually 270 Newton, right? So these forces are not balanced, right? So finally the resultant will always be, okay, the particular, so finally if you see these two objects, right, or we can say the cylindrical block and the wooden block, or this particular system will actually, because the force downwards is more, right, so this will actually fall down, this will actually accelerate down with the acceleration of 0.1 meter per second. We know it shatters and this acceleration falls with. So here if you see, this particular force acting will be actually finally the resultant will also act downwards because the system falls down. Right, so that is the reaction forces. If you see, as it shatters, obviously this force is not more when compared to this. If this force was actually equal to this, then the system will be at rest, the glass will actually not shatter. All right, so with this note, let's actually quickly do one more question also. Okay, let's see. Okay, let's see let's see, you have two blocks, right? Let's say this is M1 and let's say we have another block over here. Let's say this is M2. Just kept one next to another. You're applying a force for both the system, but to M1. To M1 you're pushing. So both of these will start moving. Okay. So what will be the common acceleration produced over here? So force will be equal to mass into acceleration. Mass over here is M1 plus M2. Okay. Into acceleration. So the common acceleration will be force by M1 plus M2. That's how you get the common acceleration in both these cases. Okay. Now, if you look at the system individually, right, if you look at system M1 individually, right, you are applying a force F over here, right. So, because of this mass will push this mass M2, right. You are applying a force F1, so M1 will push M2. Because M1 applies a force on M2, there will be this is action, means there will be a reaction force. That is, M2 will actually push M1 with the force F again. Okay. So if you take the force M2, right, there will be a force acting from M1 to M2. That will again be Fy. Whatever is the force that M1 pushes the M2 with, the same amount of force, M2 will push M1 as well. Okay. So these are the two forces acting on this particular system over here. Now, if you see what is the mass of this, but if you see the if you want to write what is the acceleration of this block over here, okay, the acceleration in the second block, F is equal to what? Mass into acceleration, right? In this case, if you're writing this particular acceleration, if you want to take, you can actually write, for acceleration you can write M2 into F by M1 plus M2. Okay, so if you want to find what is the reaction forces over here, if you know the total force, if you know the individual masses, then actually you can find this reactant force using this formula over here. All right, now let's do one more question before we end the class. Now, let's say we have three systems. I'm really sorry, just a second. Okay, let's say three masses. Let's say this is mass M1 over here. Let's say we have another mass which is M2 over here, right? Let's say we have an even bigger one over here, mass M3. Okay, now all of these are connected by a rope. Okay, and there is a force, and we are going to connect a string and actually pull the string over here. Okay, so as you pull the string over here, this particular mass will start accelerating, it will start moving, right? Because there's a string attached here. Through that string, you are actually pulling the rope, right? So if you're pulling the rope of force over here, then what we get? The mass over here, this particular force is going in this direction, so this gives you an acceleration, right? Now, okay, this one will actually accelerate, right? Now, let's see, the tension forces in this on the string will act on this way. Okay, M1, right, on this case, M1 will pull this particular M2 with the force. So this one also will have a reaction force over here. So with these two forces will be tension forces, right? Similarly, this particular mass will apply these two will also apply a force on each other, right? Whatever force M1 is pulling M2 with, M2 will pull M1 with the same force. Whatever force M3 is pulling M2 with, M2 will again pull M1, M3 will apply a same force on this rope over here, right? They are interconnected and there will be tension forces acting everywhere. What we want to find is what is the value of this T, we want to find how to find this value of T1 and T2. Okay, now let's say the mass of each of them, let's say this is around 5 kgs and let's say this is 10 kgs and let's say this is 15 kgs. Okay, then let's say the total force that we applied initially, let that be 50 Newton. Okay, now from here, for all of this object, the common acceleration as you pull, the entire system moves, right? The common acceleration you can find, right? Because force is nothing but mass, in this case mass of all the three objects M1, M2 and M3, right, into its acceleration. Okay, now, so from here acceleration will be force by mass M1 plus M2 plus M3, right? So this is easy. This is 50 Newton and what is the masses? This is given by 5 plus 10 plus 15, right? So this is around 20 plus 30, right? So acceleration in this case will be 50 by 30, which is nothing but 5 by 3 meter per second square. That is your acceleration. So let's write that over here. Our acceleration is 5 by 3 meter per second square. We have found this value. Now, this is the first thing we have found. Now, if you want to find the forces that is acting on this particular object, right? Tension T1 and T2, we are going to take the free body diagram of each of the system, right? So, first, let's actually take the first object over here, that is mass M1, okay? This also has, acceleration is common across everyone, right? So, this is going to accelerate in this direction, that is one vector force that is acting. The other one is acceleration is acting, other force vector that is acting is, that is the force is tension T1, right? So if you want to find the tension T1 over here, this tension will be equal to, it is accelerating, right? The system is actually accelerating, right? So this tension will be equal to the force acting on the system, right? The force acting on the system, the resultant force will be equal to this tension over here, right? The force of the system will be what? Very simple, mass into what is the mass it has and how much it is accelerating. That is the resultant force. The resultant force that is acting on the system, this is equal to the tension force. The resultant force, how you will write from the second equation of motion, m1 into a, right? So acceleration, we know this mass is 5. Acceleration due to gravity, we know it is 5 by 3, right? So this is around 25 by 3. So the tension T1, if you see its value, 25 by 3 is somewhere around 8.33 Newton. This is tension T1. Okay, this is the tension on this rope here. So this side also the tension is T1 over here, right? Now, again, if you want to find what is tension T2, right, we are going to make use of the third one over here, right? Third mass, this is actually M3. Okay. Now, M3 has an acceleration in this side, right? It has a tension force acting on this side and M3 is actually moving with an acceleration because of forces applied. It's moving with an acceleration, right? It has a mass and it has an acceleration and its force is in this direction. Right? Now, if you look at the resultant force, the resultant force which is making this object move, that is actually equal to, this is the resultant force, right? This resultant force is actually equal to the force because as a result, the entire system is moving this side. So, this force is in that direction, right? This force minus, this is the force which is acting T2. This tension on this rope is acting in the opposite direction, minus T2. Okay? So, here, this particular resultant force when you're talking about, it is actually the force applied on the system, right? The force applied is what? This is nothing but mass into acceleration from Newton's second law. Mass we know, right? Mass we know is actually around 15. In this case, mass is 15 kgs. Acceleration due to gravity is 5 by 3. We found that value. This is equal to, we know the force applied here over here. We took the force applied to be 50 Newton minus T2. Right, solve for this. So this T2 will be equal to somewhere around, somewhere if you solve for this, you will get the T2 value as somewhere around 25 Newton. So that's the tension on the string over here. This is around 25 Newton force acts over here and 5 by 3 Newton, sorry, in this case around 8.33 Newtons of force acts around here. Okay, So with this note, we are coming towards the end of the session, and once again, we have this offer, that is plus subscription right now is 20% off. That is only available up to tomorrow. So if you're planning to take a plus subscription, now will be the great time. So for class, if this for you to avail the 20% off, you should take a plus subscription 9 months or above. Okay, and generally with Unacademy, if you're taking for a longer duration, the price per course goes down. Okay, so for 9 months, you're paying only 14,615 rupees, and you'll get an amount. You'll be saving around 2,578 rupees. For 1 year, you'll be paying 16,863 rupees, and you'll be saving 2,975 rupees. Now, for 2 years, if you're taking, that is 28,104 rupees, and you're saving 4,959 rupees. Okay. Now, once again, you can use my code MTIS10 to avail the 20% off. And also, you can do various payment methods, and also you can, if you're taking for 1 year and more, I think they can also pay through zero cost EMI also must be available for you guys. All right. Now, if in case you're in class 11, we have a plus course that is going on. That is actually the Brahmastra. This course started on July 6th. The course will be taught in English. For physics, we meet every Tuesday, Thursday, Friday between 5:15 to 6:15 p.m. And if you're in class 11, you have an advantage. If you're in class 11, if you're taking class 11 subscription, class 12 subscription is absolutely free. You're paying for 1 year, you're getting the benefits for 2 years. Okay. Again, whenever you're taking plus subscription, you're getting 4 subjects. Now, just like for class 11, for class 12 also, we have a plus course that is going on. This is actually your Achievers course, which again started on July 6th. And the course will be taught every Monday, Wednesday, Friday between 5:15 to 6:15 p.m. Okay. Now, we are introducing the community feature. The link to my community will be given in the description box. Go to my community. There will be a lot of MCQ type question asked. So as and when you're taking YouTube sessions, you can try going there and try and answering the questions asked over there. Okay. Mostly there right now, you will see only questions from Unit 1 and Unit 2. But just try going through it. Okay. And at the same time, you can also share your feedback directly via poll. And in case in any of the videos, if you're seeing any content that is appropriate and you can report, if you're reporting the same, you can claim a prize. All right. So with that note, we are ending the class. If you like the session, please share the session among your friends and subscribe to the channel. And I'll see you guys in the next class. Okay. So again, we will have another class, I think tomorrow again around the same times. I see you all then. We will be learning more about friction, and see you guys in the next class, and click on the bell icon for the notification.